a short episode on asteroids, meteors, and comets with Daniel T Andreason on episode 339 of the Actual Astronomy Podcast. I'm Chris, and joining me is Shane. We are amateur astronomers who love looking up at the nighttime sky, and this podcast is for everybody else who likes going out under the stars. So today we're going to talk about asteroids, meteors, and comets. But first, welcome back to the show, Daniel. It's been a lot of fun doing this series of recordings with you here this morning.
Yeah, thank you. It's good to be back.
Not really sure why Siri is misbehaving, but we'll just roll with that. So I was going to say, it's just like we spoke a few minutes ago. Good stuff. So we're going to begin. Maybe first, let's talk just very quickly about the difference between, say, an asteroid, a meteor, and a comet before we kind of dive into each of those topics.
Yes, they're quite different objects, and it's a bit confusing for people, even for me sometimes when I don't pay enough attention. And just quickly, asteroids, they're usually in the asteroid belt, which is located between Mars and Jupiter. Some huge stones, some smaller. Then we have meteors, and meteorites and meteoroids, which is just very small rocks that are in collision with Earth. And then we have comets, which are leftover objects, which usually are in the outskirts of the solar system and once in a while take a little trip into the inner solar system.
Let's start with asteroids. Where are most asteroids located in our solar system?
Yes, so you might be aware that the fourth planet from the sun is Mars, and then the next one is Jupiter. And in between those two planets, we have what we call the asteroid belt. Here we have so far nearly 1.3 million asteroids that we know of. And they are ranging in size from a few meters to some 100 kilometers. And the total mass of all the asteroids are less than our moon. But it's also because at least a few of the objects like Vesta and Ceres has been classified as dwarf planets, which we can talk about in another episode.
I was just going to say the asteroids are pretty spread out, though. I always think of that scene from Star Wars where they're kind of just sort of like, going around the asteroids, kind of like a skier going around the gates or like doing like a slalom or something. But if you were standing on an asteroid, my understanding is like that next asteroid would be so far away, it would just look like a dim star in the distance, kind of moving against the background stars.
Yeah, that might be it. But that dim star might also be hurtling towards you, and it's difficult to see because it's just a small rock. I do not recommend anyone standing on asteroids, for the record.
Good to know.
Don't try this at home.
Don't try this at home. Professionals only.
Yeah.
So what are asteroids made of exactly then?
Usually they are just rocks like we would know it from Earth. But of course, our rocks here on Earth are being changed according to anything that happens here on Earth. And on asteroids, they're just constant. They are how they were whenever they're created. They don't usually have an atmosphere because they are quite small, so they cannot hold on to an atmosphere. And some might contain some water, like what we used to call the asteroid Ceres, which is now a dwarf planet. And we have seen around 150 of these asteroids. They have one or more moons, which is quite interesting. Asteroid moon. This is something new that I also learned. But some are just roughly the same size, and they just go around in a binary system, like you would see with stars sometimes. Sometimes these can be hurtled out of their orbit and have a close encounter with some larger objects like the Jupiter or Mars. And we did see that some of these asteroids that had gone out of the belt for some reason or the other, they can be trapped in these special gravity points that are around Earth, also called the L3 and L4. And you might remember that one of these points, I think, is the L4 or L2. I think it's L2, where we put a lot of satellites. Anyway,
and I think the James Webb is in one of these Lagrangia or L3 or L4
exactly.
points. Yeah, I can't recall which one it is.
I can't recall either. I think it's L2, but yeah, we have a lot of telescopes there. For example, the James Webb, and the largest population of these Trojan asteroids are around Jupiter. But we discovered our first one here on Earth back in 2011. So it's not that long time ago that we found our own little Trojan, and we can call it our second moon, which I find is quite nice. Usually we're not familiar with the second moon of Earth.
Shane, you're a meteoroid man. Do you want to chat about the meteoroids?
Yeah. So I guess, Daniel, just what is the difference between meteoroids, meteors, meteorites?
Yes, I have to be honest. I had to look this up myself because I always get confused. So when it's outside our atmosphere and there's a small rock, it can be anything from just a little dust grain to some of the smallest asteroids. We are called it meteoroids. These have the potential to be something else. And when it hits the atmosphere and burns up, it's called a meteor, which is also what we call a shooting star. And a lot of the shooting stars are what we see from the dust left behind comets, as I will talk about in a second. And if this small rock survives the trip through our atmosphere and hits the Earth, and you can find a leftover, it's called a meteorite. And most of these meteoroids, the ones that have the potential outside our atmosphere, they come from larger objects like comets, as I said, but it could also be asteroids. But it can potentially also be from the moon or some of the other planets. Maybe there is a impact on the moon, and some of the material that is thrown up from the moon might eventually hit Earth. And some of the largest meteors can be brighter than Venus, and they are known as fireballs. These are the big shooting stars, so to speak. Mm-hmm. And I've been lucky enough to at least see one, and it was quite a sight. And I was very surprised when I read this, but it's estimated that nearly 50 tons hit Earth every day of space material.
Wow.
That is an enormous amount of material. I didn't have time to double check the numbers, but I do know that it's quite a lot that hit Earth each day. But most of it burns up in the atmosphere, so we should not start going around with umbrellas and hope that it can stop some of these.
Yeah, the fireballs. I've seen a couple. I think I've seen actually maybe 3 or 4 in my times out observing, but I've only been fortunate enough to be looking at the right place at the right time to actually see it happen. The other 3 times or so, I've been looking in my eyepiece case, and everything brightens up around me like it's daytime. And then I turn to look and I've missed it. But the one that I did see, it was incredible just how bright it was and the trail it left. It's one of those situations that I don't think I'll ever forget. It was really just like, wow, I can't believe what I just saw.
Yes, me too. I remember I walked home from university a day after a few beers, and immediately I didn't feel the effect of alcohol any longer. I was so excited. And I remember I saw that it broke up, so there were smaller pieces falling through the atmosphere. It was an amazing sight.
Yeah, it really is. And you just have to be, very lucky, right place, right time, looking up at the right area of the sky. And, it's easy for some of that to not happen.
Yes, but we definitely have an advantage over other peoples because most likely we are looking up more time than other people. I know every time it's dark outside and there are no clouds, I always look up. Not because I expect to see fireballs, but I just like to look at the stars, and I might see some other interesting things while I'm looking.
So what about meteor showers? How do those fit into this equation?
Yeah, so I talked a lot about all the random things that might just fall through the atmosphere, but if we have a comet flying by, it will leave a dust trail, and this dust trail we orbit into at the same time every year. So it just leaves a shower of meteors, so to speak. So we can predict when it's going to happen, in which direction we're going to look, and when the maximum is going to be. So if you ever want to see some meteors, just see when is the next meteor shower. But I have to say, not every time, but every second time or third time I'm out, I might see one or two meteors. Mm-hmm. It's not that rare if you pay attention and just look up.
Yeah, we're getting closer to the Perseid meteor shower in August, which is one of the better ones throughout the year. It's certainly for us northern observers, it's the warmest one with the greatest amount of activity or potential, I guess, for greatest amount of activity. But the thing too with meteor showers is timing. If it's on a new moon weekend, then you're probably going to see a lot. But if there's a moon in the sky, sometimes that'll wash out, the amount that you're able to see. So maybe we should dive into the last aspect here, Daniel, which probably gets the most fanfare when there's a bright one of these things. But let's talk a little bit about comets. What are these, and where are they located?
Yeah, good questions. And they are very interesting objects. And we just had one recently, right? Mm-hmm. In the beginning of the year. And I remember I also went out to have a look through my binoculars. Mm-hmm. They are beautiful objects, which are kind of leftovers from the beginning of our solar system. And coming from Denmark, I remember we always talked about these as the Lego that is left over when we assemble something. Just to be sure that I say this because Lego is here from Denmark. Mostly it's just ice. It's just huge, dirty snowballs because there are also some organic materials on them. Hurtling through space, and actually it's interesting since they have a lot of water in form of ice and some organic material. They might actually have brought a lot of this water and some of the building blocks for life on Earth in the earlier times of the solar system. If these hit Earth, because in the beginning of the solar system, everything was much more violent, smashing into each other. So it's not unlikely to think that we will be hit by some meteors. Many of these, they orbit near the orbit of Pluto, which is the furthest X-planet now. It's just a dwarf planet. And they take a couple of 100 years to orbit around the sun. And we know this because we have actually records of many of these, because they were discovered centuries ago by just normal people looking up at the sky. They don't even have to be astronomers. I remember seeing some of these comets with naked eyes, and they're really spectacular. There's something unlike anything else we see in the night sky. Some other comets, they're even further out in what we call the Oort cloud, and they can take even millions of years to complete an orbit around the sun. So these are not something that we discover and then wait for the next time they come around. Take way too long. As I said, the core is mostly ice and some frozen gases, and they maybe have a size of a few kilometers. And when they get closer to the sun, some have very strange orbits, not so circular like most of the planets. They can be quite elliptical. So when they get closer to the sun, it starts to heat up and they form like an atmosphere, which we call the coma. And all the gases and ice that are trapped on the comet, they're the ones start to evaporate and form this atmosphere around the comet. Now we get to the good stuff. The pressure from the sunlight and the solar wind make comets amazing. They create these tails that can be thousands of kilometers behind the core of the comet. And the tails are what most people talk about when they talk about comets and remember. And we have two kinds of tails. We have a dust tail, and this is when the comet is heated and gases are released. Then dust is dragged out with the release of all of this gas. And the dust tail follow a curved arch behind the comet, away from the sun. And the tail is visible from the reflection of sunlight. Then we have the gas tail, and this is some gas that is ionized by the solar wind, and it points straight away from the sun. And it's visible since it's ionized, and then it emits light. It works kind of in a similar way as auroras, and they are beautiful. And usually when we look at comets, we want to see both of these tails.
Do you have anything else to add to this episode on asteroids, meteors, and comets for the listeners?
Definitely for the meteors and mostly about the meteors is really just to look up. You might see quite a few, and it's always fun to see. For comets, it requires a little bit more planning, and asteroids is something I didn't observe myself yet, but it could be fun to hunt down.
Very good. Shane, do you have anything to add to this episode?
I just will maybe quick summary. There's a lot of interesting things in our solar system to observe. You know, the first few episodes, Daniel, we've talked about a lot of things way out, and it's kind of neat that these are closer. But what I like about these objects that we've talked about tonight is its motion. You know, you can see motion through your telescope typically. You know, the asteroids and the comets, you may need to sketch and then, you know, sketch the object in accordance with the background stars and come back an hour or two later and you know, then you'll be able to observe the movement. But being able to see that is a unique thing. When we're talking about nebulae or galaxies, you're really not going to see that movement at all, even though they're an active system or object. So anyway, I'm always fascinated by solar system motion, and I'm glad we talked about some objects where we get to see that stuff.
I agree.
Thanks for that, Shane. Thanks, everybody, for listening. You can always reach us at actualastronomy@gmail.com with your show ideas, observations, and questions. Thanks so much for listening.
Thank you, everyone, for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.